So question 2's instruction was to simplify the following, and we have two algebraic expressions here. We have negative 2a multiplied by a bracket of a squared minus 3ab. So simplifying this case would mean to multiply the bracket out. Right, so multiplying out this bracket means doing this. Some of us still use those arrows. Arrows just indicate that you're multiplying the number outside the bracket into the bracket. And we would do it for both terms inside the bracket. So I would get then negative 2a multiplied by the a squared, and I will get negative 2a to the power of 3, because that's a multiplied by a to the power of 2. So laws of exponents, I need to add my exponents. So there's a 1 over here, of course, and 1 plus 2 will give us a to the power of 3. And then I will do the same thing with the next term. Now, the mistake that was made here by some of you is you forgot that this has a minus sign, and when I multiply this term in there with the second term also has a minus sign. So negative times a negative is a plus. And some of you forgot that and you wrote minus here instead of plus, and that would of course have given you an incorrect answer. So you would lose the mark for the second term. And only you would probably have gotten the first one right, so you get a mark for the first term and lose a mark for the second term. Nevertheless, multiplying in the term outside, or the number outside, with the second term, I would get then plus 6a to the power 2 and b. So that would be your final answer. There's nothing more I can do to this. These are not like terms, so I cannot add them, so that is where I stay. And that would have given you 1 mark for that, and of course another mark for the second term. Okay, 2.2, we have a product of two binomials, or two brackets here, and that is of course a multiplication sign between the two brackets. We've got bracket 1, bracket 2, and I can notice that the first bracket has an a to the x as well as the second bracket, and then the second term in both brackets are also the same. It's b to the 1, b to the 1. The only thing that changes here, or is different, is the plus and minus signs, or minus and plus signs. And this form, it should remind you of the a plus b, a minus b, that factors, or that way of writing two factors in brackets, would result eventually in a squared minus b squared. In other words, this is the factored form of the difference of two squares. So if I notice that, or if you pick that up, then your answer you could go straight to saying, well, this means that is a to the power x raised to the power 2 minus b to the power y raised to the power 2, or in other words, I've got a to the power 2x minus b to the power 2y, because I recognize the form, I recognize the pattern. I can see here that I've got the same roots in both brackets, and it's separated by a plus and minus, one in each bracket, or alternatively in each bracket. And I'm calling them roots because I've recognized the pattern, because once I multiply these guys out, I will eventually end up with the squares. Okay, so these guys are the square roots of the square. That's the square root of the square. If you did not see that, let's say you didn't see and you wanted to just multiply this out and see where it gets you. Let's say that you said, okay, I'm going to take a to the power x and multiply it with a to the power x. I would then get a to the power x plus x. And let's show all the steps. Then I would say, okay, I've got a to the power x times b to the power y. That gives me a to the power x, b to the power y. Then I have, let's just clear this away. Then I have negative b to the power y times a to the power x. That gives me negative a to the power x, b to the power y. And then I have negative b to the power y times b to the power y. And that gives me negative b to the power y plus y. Simplifying this, a to the x plus x is a to the 2x. And then I can see that this term and that term are identical, and they are additive inverses of each other. In other words, they cancel out to 0, they add up to 0. So that disappears, and what's left is of course minus b, and that y plus y is 2y. So that would be a to the power 2x minus b to the power 2y.